Alright guys, so we're in a section, I split it off, I probably should have kept it together, but we're in a section that's called decomposing, the decomposition of functions. And how I want you to think about it with this is that it's like probably like the more prettier things in math, right? Where it gives you this opportunity to focus on your algebraic skills. We're in a place where we're doing a lot of analysis, and now we're doing our algebraic skills. So let's say with the composition, let's say we want to compose f of g of x, or we might see it as f of g, right? Let's say f of x equals I don't know, x cubed plus 5x, right? Let's say g of x equals x minus 2, right? So recall that our goal is to replace all of the x terms in f of x. Oh, too much pink right there. Too much pink. So all of the x terms in f of x with all of g of x. So what I'm going to do is I'm going to make a little place here. I'm going to make a little place here, and I'm going to show you what I'm replacing. All right? I'm going to show you what we're replacing. I'm going to write g of x in that little pink. So I know x is cubed in f of x right here. We're going to f of x, and it's cubed, and then plus 5 times another x times another x. All right? So what is our new x? Our new x is going to be this group, x minus 2. So x minus 2 and x minus 2. And you could go ahead and just make that simplified, but we don't want to do that. We just want to point out that we now have g of x inside of each x term of f of x. So let's look at this problem here. We're decomposing, so we're pulling things out. We've put them together, we decomposed it, and now we're pulling it out. So we want to find f of x and g of x in this new function h of x. So what I'm going to do, I'm looking for the same group. Same group for each term. Is there a same group for each term? So if I look right here, I see x minus 5 and x minus 5. And let's replace that with g of x. We have 2 g of x, and it's squared, plus 2 g of x. And so we'll say, like, let's say g of x equals x minus 5. Okay? Let's see if this works out. I saw the same, I looked for the same group, and now I have the same and the same, and now I can pull out g of x and replace it with x. So we're moving backwards this time. So we have 2 x squared plus 2 and x equals 2 x squared plus 2x. Dude, so let's look at the directions here. So it's given that h of x equals f of g of x. Find f of x and g of x. So f of x would be 2x squared plus 2x. And it works out, guys. It works out. So a little fancy magic there, a little algebraic skill there. All right? So looking at this new h of x, what could our g of x be? Remember, it's always inside of the main group. So the best probably, like, let's try g of x equals x squared minus 3. Let's see what happens. So I have equals the cube root of g of x. That works out. I could deal with that. And f of x must be, let's replace it with x. Let's replace g of x with x. F of x must be the cube root of x. Amazing. All right. So you do the work for the last one. I know already that g of x equals x squared plus 5, and f of x equals 2x squared. So show the work for it like you did before, and you should be good, guys. Let's see what's next. So this part, this is a separate part. We're gonna separate the videos for this, and it's based off our work with composition of functions and its inverse functions. So I'll stop the video here and do inverse function.